Hey, Stefan.
Hey, Makamana. I think Stefan's still muted.
Matthew, I think you have to start. Stephen has some issue with his mic.
Okay. Right. Well, I have to. He's displaying it at the moment. So, Stefan, if you can move to the next slide when I need to. So, welcome to the Bess working group. Here is the note well. If you could just look at that for a second. This is basically says anything that you say here is a contribution to the IETF. Next slide. Okay, so you're in Mediteco, which is a great start. If you'd like to speak, please join the queue, and the chairs will manage the queue. But wait for your name to be called and then unmute yourself, please. Okay, so RFC 7432 BIS. So this is an open action that we've had for about a year now. There's a presentation on it on the agenda. at this IETF. The chairs have discussed this, and we intend to publish this directly as a working group document if the working group has no objection to that. Seeing as this is on our work to-do list, to do this update to an existing RFC. I'll just give a second. If anybody has any concerns with that, please jump in the queue now. I don't see anyone in the queue, so thank you. Stefan, next slide, please. Status update. So RFCs published since the last IETF. We haven't published any. We have 4 documents in the RFC editor's queue: the EVPN overlay, DCI EVPN overlay, EVPN prefix advertisement, an SH BGP control plane, and the revision of RFC 5549. There are quite a few drafts currently with Martin or in IESG review. So there's the NA flags draft, into subnet forwarding, optimized IR, proxy ARP, and open discovery. The bump procedure updates, the OEM requirements framework for EVPN, and then the DC gateway draft as well. Next slide, please. A number of documents are currently in our queue for being reviewed by the shepherds. So Mankamana is reviewing the IRB multicast draft. We're waiting comments. Do you want to say anything about that, Mankamana?
Yeah, so I have finished reading about most of it, this document, and I'll be sending comments to authors soon, and I'll come up with the write-up as well.
Okay. The unequal load balancing draft, we need another short working group last call for that. The EVPN virtual Ethernet segment document, the write-up is done, and there's some follow-up going on between Luke and the authors. The VPN preference DF, Stefan is following up on that. And the IGMP MLDB proxy requires a... Stefan's here now. Yes, we can hear you. Hi, Stefan.
Okay, no.
Did you want to say something? Okay. The IGMP MLDB proxy, we're expecting a new version of that to be submitted as soon as the gates are open. Stefan, do you want to take over? It's gone again. Ongoing polls. There was a poll for EVPN LSP ping. We had some comments from Laura, I think it was, regarding the IANA section on that. So this needs to, we think this needs to be updated before we can close the poll. And check with Laura as well for the updated section. We also need a poll on that to address the issue of implementations. I don't think we had any replies about whether anybody had actually implemented this. So we're going to need to do an explicit implementation poll or an explicit poll to check if the working group is okay, given our policy for only publishing standard track documents with implementation. At least one implementation. So we will check the working group is okay with that. We have an ongoing working group last call on the IPVPN interworking draft. Stefan, next slide, please. Okay, ready for last call. SRv6 services. So these are in our queue. We will likely start a working group last call for these shortly. So SRv6 services, the EVPN aggregation label, the IRB extended mobility draft, which has a couple of dependencies on other documents that might hold it up. Next slide. Working group documents. So the DF election draft, multicast DF election draft. So we've got a new update that is likely to be posted. We expect this to be ready for working group last call for the next IETF. And this is planned to be presented at this IETF to get more comments on the draft. So you should see that on the agenda. The FastDF recovery draft, there's no update to that, and we're following up with the authors. Luke, you are next. Hi.
Just for the FastDF recovery, we did do an update sometime last spring, and actually went and got some INA code points allocated. So maybe I can present that one at the next IETF, or even if there's a last column.
Great. Okay. Thank you. Next slide, Stefan. So we haven't had any updates for this list of drafts on the slide. Next slide. And we have some new working group documents that we've recently adopted. So the VPN multi-home split horizon was adopted in October. The BGP SD-WAN usage draft adopted in July, and EVPN SRP2MP was adopted in November. Next slide. A couple of other documents that are probably ready for working group adoption. Draft preset Bess EVPN L2 gateway protocol, and draft Mohanty Bess weighted HRW. Okay. So here is the agenda. I just realized we didn't do an agenda bash at the start. So any comments on the agenda while we're waiting for the first slide to come up? So I think the first one up is Luke Andre.
It will be the GAN method. Here we're going first.
Yes, can you hear me?
Yep.
Okay. All right. So this draft IPv4 NLRI over an IPv6 next top. So this draft utilizes the RFC 5549 IPv6 next top encoding scheme. So we have the authors myself, Manik Mishra with Cisco, Jeff Tensura with Abstra, and we have a new member to the draft from Juniper that has recently joined, Lily Wang. So with this draft, overall, we've made some good progress as far as some intermediate like interoperability, just support of the RFC 5549 next top encoding related to eBGP peering sessions. And really the goal of this draft is to test the interoperability as well as first determine whether it's supported the feature and functionality, that everything's fully functional. And you know, with some of the bigger vendors like Cisco. So far in the group of vendors that we have so far, we have Cisco, Juniper, we have Arista, as well as Nokia, and we're also trying to get Huawei on board as well. So that would be like really the top 5 vendors that we're looking at doing the interoperability testing of this. Next slide. Thanks. So just an overview of this draft. So what this draft does is it utilizes the IPv4 next top encoding, IPv4 NLRI over an IPv6 next top peer that's been used. It's very similar to what's been around for decades, where you have a v4 edge or v6 edge over a v4 core, and your PE to RR peering, an iBGP peering is where you're encoding your v4 v6 NLRI over a v4 next hop. So similarly to that, with RFC 5549, we're kind of doing the reverse. We're taking a v4 edge and we're encoding over a v6 next hop. So with that, What this does is it's utilizing that same peering that's been done, for a long time, with a 4-edge, a 6-edge, sorry, a 6-edge over a 4-core. Now we're doing a 4-edge over a 6-core, but utilizing that same concept for your PEC peering. So your edge peering, and the reason behind that is it really allows us to eliminate all of our dual stacking that we have at the edge, and that's like really the massive gain with this, that we're able to treat the just as we stack SAFIs on our P to R peering, where you have your VPN v4, VPN v6, and many other SAFIs that are stacked in your P to R peering. Similarly, what we're doing is we're actually using that v6 peer, that single peer, to transport. So now we're able to transport the v4 NLRI over the v6 next hop, thereby eliminating that peering. As far as the savings, it goes, you really, from an IPv4 address depletion perspective, you really, that's really a really huge major gain. And as far as address planning as well for IPv4, the other big gain is OPEX savings in terms of monitoring of peers from an NMS perspective, net confidentiality perspective. That now you have, basically you cut down your peers in half, so you don't have all the dual stacking and edge peering. Where now you really are able to, and there's really across the board that just would apply to really anywhere, whether it's a core, data center, any type of infrastructure that you have, wherever you have dual stack peering, you can keep the concentration of dual stacking, if word exists, keep it consolidated toward the edge at the customer edge, but on the peering points from the customer to the core, that can be purely v6 only. So that's really the big major gain. Next slide. Next slide. Yeah, there you go. That's good. That's good right there. So this is current. So this is a depiction of a typical like IXP peering NAP, where you could have really gain really tremendous gains, where you have, let's say, a massive IXP NAP where you have thousands of peering points where you're dual stacked, and so you have separate v4 and v6 peers. So here you can see you have separate peers, and you're carrying your v4 peers carrying your v4 NLRI, and your v6 peers carrying your v6 NLRI. Next slide. So what with this encoding scheme, what ends up happening is now instead of having two separate peers, you have a single peer. So it's a single v6 peer, and you can see like at the top in red, the next hop, so you're carrying the NLRI, let's say 192.1.1.0/24. The next hop is a v6 next hop. So you have that single v6 peer, and it's carrying both the v4 NLRI as well as the v6 NLRI. As far as operational considerations when that happens, they should be minimal. The one thing that that does exist, you do have, it's a single you have a single physical interface. So you would have, because it's not dual stacked anymore, you would not have two separate BGP sessions, BFD sessions. So you'd have a single BFD session. That should not be an issue. I mean, as it is a single physical, let's say a fiber. So if a fiber cut happened or a link went down, you'd lose both peers anyways. But it's so I think from that perspective, from the layer 1, layer 2 perspective, whether you have two peers or one peers, it doesn't really matter from that perspective. From a I guess a learning curve or operations support perspective, what does change is that now instead of having two physical peers, now you do have one peer. So with that peer, the configuration from a routing perspective, there's really no change. The policy is applied at the address family layer. So your routing policy that exists separately, let's say on a separate v4 peer or v6 peer, now it's on a v6 peer, but you still have your same separate v4 routing policy. So next slide. So this depicts the typical core that exists, for many years, I guess. And this is like showing a v4 edge, a dual stacked edge going over v4 core. PE to R peering. So what I was describing earlier, where you have a V6 edge, so you're doing V6 NLRI over a V4 next hop. So you're doing a V4 next hop encoding. And in this case, you're carrying since you're carrying V6 over V4 NLRI, and this is global table routing. You're doing 6 PE, so BGP labeled unicast 6 PE. Next slide. So in this sorry, there we go. So in this scenario, so this is a service provider core where you have your dual stacked at the core at the edge, but now you're doing this similar thing. This has existed, for decades as well. That you're also doing like what I show in red there. That you're doing, you have V6 over a V4 next hop. So your P to R peering, that's a V4 peer. So this has existed for years, and it's really common practice that you have a V4 peer and you're carrying your V6 NLRI over a V4 next hop. Next slide. So this scenario is showing a global table routing scenario. So here you could have in the core, it's a 6 core, so it could be either LDP v6, SR-MPLS v6, or SR-v6. And so with the software mesh framework, from that perspective, RC 5565, you have a 4 edge over a 6 core, and here your PE to RR peering, you have you're running like 4 PE, so you have IPv4 NLRI over an IPv6 next hop. So you're doing BGP labeled unicast 4 PE, similar to the 6 PE, but you're carrying your V4 labeled unicast over a V6 next hop peer. And then as you can see in the PEC connection here, it's a single peer. So here you have your AFI 2/1 is carrying your green 1/1. So your V4 peer AFI is basically stacked on top of your V6 transport, carrying both address families. Next slide. So this is the service provider core perspective where you have the VPN overlay. So similar six cores, so MPLS like LDP v6, SR-v6, or SR-MPLS v6, and then you have on your P to R peering, you have VPN v4 carried over v6 next hop, IPv6 next hop on your P to R peering, and then here your PECE peering. And this is where the major gain is, that now we can eliminate all of our V6 or dual stack peering, save all that V4 address space at the edge, and completely eliminate that, and just make the entire edge completely V6 only. So carrying both the V4 address family over the V6 next hop.
Go on, you have 1 minute, please.
Okay. Next slide. So as I mentioned at the very beginning, we have made some good progress. The 4 vendors so far that I've contacted we have Monica Mistral with Cisco, and then with Juniper we have Lily Wang, and then with Nokia and Arista, I've contacted them. We're working on getting some contact information for the interoperability testing, but we have made some really good headway so far. The 3 of the 5 vendors in total that we're looking at, they do support the eBGP PEC pairing with a single peer, and they do see the major advantage in doing this. So I think we're probably getting close to work group adoption, I think, but I want to get some feedback, I guess, from folks on Bess to see what everyone's thoughts are on this. So I'd like to open up for anyone has any questions or comments or anything related to this draft. Thank you.
Thanks, Garen. I don't see anyone in the queue. We're very tight on time. One, AC. Go ahead.
AC Lindum, Cisco. Can you hear me?
Yes.
Okay. It'd be good now that we've got the 5549 BIS to indicate compliance with that as well in your testing.
Yes, definitely, definitely. So we'll, as part of the testing, we'll definitely be testing that, the updated BIS, with the next hop encoding. Yes. Yep. So we will incorporate that into the testing.
Okay, thanks.
Ace, do you, any comments or like, like with the overall, with the gains that we would gain from this, or any comments? Yes.
Okay. No, thanks. Thank you very
Thanks.
much.
Thank you.
If you can, folks can review the draft and send some comments to this, that'd be good. Thank you.
Thank you.
Okay, so next is Luc Andre.
Yeah, hi. So I'll be presenting a brief overview of the updates since version 01. So the diff tool between 01 and 02 shows quite a few fixes for consistency and just changes of an editorial nature, changes to cross-references, etc. One of the major updates between 01 and 02 is a new section that was added to clarify the terminology between what a normalized vid is and service identifiers, so VPWS service identifiers, and sort of serves to disambiguate between the two terms. After that, yeah, so there was this draft also proposes to extend the EVPN layer 2 attribute extended community by 2 new fields. So the version 2 of this draft addresses field alignment issues in the definition of the extension to that extended community. And also we updated the INA section to actually request allocation of the 2 new fields. On the next slide. So in a second step, there's also a clarification that's added in in 02 for the 2 fields, the mode bits and the vid normalization bits, and on how the 2 proposed fields operate. So a whole new section is added with more precise language for error conditions in usage of the V flag especially. So while the V flag for vid normalization is optional, if this field is signaled, the new section details how if and when this field is signaled and a mismatch is detected, that represents a serious error in the data plane, in the vid encapsulations on the sending and receiving E. So the section addresses how that mismatch needs to operate to prevent tunnel instantiation, not just raise an alarm. The operational mode, so the M flags or field, sorry, is maintained as optional and error notification only rationale for that field. So what are the next steps for this draft? It is an implemented draft. It does show good adoption. So we would like to see some more review and comments on it. I've received one already on the V02 version, so there will be a small update. But eventually, this draft is ready to move through the working group and is last call ready. And that is the short update.
Okay, thank you. Don't see anyone in the queue. So next, I think is Man Commander.
Yeah, so hey guys, we'll give a brief update about per flow DFLX and draft. So we can go to the next slide. So this is just a problem statement recap because it has been quite long. We spoke about this particular draft. So this draft defines a new DFLX mechanism and why exactly it is needed. So right now we have a couple of DFLX procedure. One is default DFLX procedure, which is defined in 7432, which is nothing but per EVI ESI DFLX. And the other DFLX mechanisms are when we use HRW algorithm to distribute DF among multiple Ps in the multi-home scenario. But we had, there are a couple of customers who wants to use eVPN multi-homing and the whole multicast services on a single VLAN. So if we have such scenario, in that case, always there is only one P who is going to be a DF. It means that the whole multicast traffic is going to get carried or get forwarded by your one of the P. So even though we do say that it is operating in all active multi-homing, but we are not utilizing the other link at all. So that is where this new mechanism comes into the picture, where we are going to have a per flow DF election. So Stephen, we can go to the next slide. So in this scheme, what is going to happen? So by default, when eVPN service is configured, we are going to have a default DF election, which will set up their state that one of them will be the DF and the other guy is non-DF. For example, in this, P1 is in the DF state and P2 is non-DF state. So reason why we have a default DF election being done is for your broadcast and unknown unicast traffic. And what happens that when we get a first join, so let's consider the red join, which is for SG1. So when join reaches to P2, we have IGMP proxy procedures to synchronize this join to P2. And at this point of time, for this particular flow, we are going to have a DF election performed. And this DF will be providing a state for this particular flow. So in this case, P1 becomes non-DF and P2 becomes DF. When the next join comes, next join again will go over exact same DF election procedure and appropriate DF, appropriate P will take over as a DF. So in this example, we have SG2 where P1 becomes a DF and P2 becomes non-DF. The procedure which is being used is the extension of HRW. So earlier HRW was considering input as only EVI and ESI, and now we have extended it to consider even source and group, and that gives us a flexibility where each flow will be distributed among multi-home peer. Next. Next slide. Okay. So this draft has been already implemented and it is deployed, and we would like to get more comment from working group, and we plan to have last call before next IETF. If there is any question? So I think we can go to the next. Yeah. So AC-aware bundling service interface, it was a new interface defined for eVPN services, and we did present this 2 years back in IETF Bangkok. And the reason for presenting it back is we are going to basically spend time and move forward with this draft in before next IETF. So I just wanted to kind of go over it, and there have been some comments received from Jorge and Luke Andre, which will be addressed in the next revision. So it is for this IETF, it is just we are going over the same slide deck to make sure that the whole working group is aware, and if there are any comments, we can take them. So the requirement is very simple, that there are certain deployments where we want to have multiple subnets within a single bridge domain, and each subnet will be distinguished by the VLAN in the bridge domain. So 7432 defines 3 types of service interfaces, and each of those service interfaces are addressing different requirements, but none of them actually are going to provide a mechanism where we can have multiple subnet in single bridge domain. So in VLAN based service interfaces, we have one-to-one mapping between bridge domain and a subnet, or our EVIs. In the VLAN bundle service interfaces, we have each eVPN instance do correspond to multiple VLANs, but the bridge table is going to be a single bridge table. And when we do MAC address lookup, we will MAC address lookup. MAC address is the key for the lookup, and encapsulated packet will be remain encapsulated in the originating VLAN ID. And VLAN aware bundle service interface, it does provide a mechanism where multiple VLANs can be will be part of multiple bridge table. So basically, when we map any, when we look for any MAC plus VLAN or learn, lookup will be based on MAC plus VLAN ID. And either of these service interfaces are not going to provide a mechanism where you have multiple subnets in same bridge table, and they are pointing to a single IRB or single bridge table. Yeah, we can go to the next slide. So in this example, we are talking about a bridge domain, which is being shown by yellow color here, and there are 3 different subnets, and they're part of a single IRB interface. So in this case, P1 and P2, they are multi-home peer, and P3 is the remote peer. So right now, what is going to happen that when P1 originates a MAC route, P3 needs to create an entry where the next hop could be either P1 or P2. And from the P2 point of view, we need a way to identify that which subnet this MAC belongs to. So today, when if we use any of the service interfaces which is defined in 7432, it is not going to carry any information which can provide information to P2 about which exactly subnet or VLAN this host H1 belongs to. So when packet has to be sent out of P2 for host H1, P2 has no clue which VLAN should be put on this particular data belongs to the MAC H1, MAC of H1. Next slide. So AC-aware bundling service interface is going to address this particular requirement. And to address this requirement, what is going to happen that we are going to carry a circuit ID or attachment circuit ID along with the routes, whether it is MAC route or multicast routes. And the reason why this is applicable even for a multicast route, because when we are syncing IGMP joins, we need to make sure that we do carry which AC this join has come from, so that when you are creating a forwarding state for multicast in the snooping, appropriate AC can be picked. And this attachment circuit will be useful only for the multi-home peer, and it must be ignored by the non-multi-home peer or any remote site. Next slide. So with respect to control plane operations, when P learns MAC address, it must attach a attachment circuit extended community to the MAC route, and when it receives a IGMP join, it must attach attachment circuit to a multicast route, which is route type 7 and 8. On the remote side handling, when this MAC route is being received by non-multi-homing peer, it must process MAC route as it does today, defined in 7432, but it is going to ignore the attachment circuit extended community. And if it is a multi-home peer, then it must get which AC or which VLAN this particular MAC route belongs to. And even with respect to multicast route, again, it is only for the multi-home peer. And anyway, route type 7 is supposed to be processed by multi-home peer itself, and it is going to get appropriate AC or subnet based on the attachment circuit
Mankarana, can you wrap up, please? I think you're kind of out of time.
Yeah, next. So there is no data plane change for non-multi-home peer. It is going to be exactly same as 7432. Yeah, we can go to the next slide. So right now, when data is received, it does follow, from the CE point of view, it does follow the same procedure as 7432. So only new change with this will be when we are receiving the data and we are going to forward. Now the MAC address lookup is going to provide you the port plus which VLAN it has to go out on, so that appropriate VLAN tag can be pushed. And multicast packets will be forwarded based on whatever multicast state per flow state has been built. Yeah, next slide. So there is already implementation with Cisco, and we are working across other vendors also. And we have, from the last presentation, we have added Nokia and Juniper as well in this draft. And we will look for any other comments which a working group may potentially have, and there will we will request for adoption call before next IETF. That's all.
Okay. There's one comment from Vernon. Could you make a comment, please?
Hello, can you hear me?
Yeah, yeah.
Hi, Wen from Juniper. So I have two questions about the AC bundle aware service. So one thing is how we deal with broadcast traffic. If P3 send the broadcast traffic, does P1, P2, which is a multi-home, has a AC bundle interface? Are they gonna do the, yeah, could just maybe clarify in the draft? Have
Sure.
yes, so it's still gonna flood to the only VLAN based on the VLAN, right? Not all the AC, right?
Okay.
Is that true? I would think that would be the case. So it'd be good to clarify in the draft. Secondary, it mentioned on the remote P does not need to pay attention to the new extended community. But if you have inter-subnet traffic in the asymmetric IRB case, what will be the VLAN it's going to put on? So I think this scheme, the new service type introduced, require you have put VLAN in the data packet. Once you have inter-subnet routing, asymmetric IRB, it seems it does not know which VLAN to put it on. So please.
Yeah, so I think, so maybe I'll respond it. I have noted down the question. I'll respond in the list because we are running out of time. So
Sure.
Okay.
Thanks.
Thank you. So next up is Ali. Ali, go ahead.
Hello.
Hello.
Hello. Hello.
Yeah, we can hear you.
Okay. All right. This is a short presentation on the areas that we are addressing for RFC 7432. The area of improvements has been, this RFC has been around for almost 10 years. As a result, we've gained a lot of insight and experience into what are the areas that needs additional clarification, and there has been some errata on this draft, and almost all of them in the form of the clarification, and there have been also some other comments with respect to the clarification and additional explanation that we are trying to incorporate into this draft, into these bits. And next slide, please. So the area of clarification and improvements, I've listed the main areas in here. First, errata that have been logged for this RFC, and some of the errata, it basically revolves around the route label field description across multiple EVPN routes, and to basically clarify that the encoding is in the high order bit, and some editorial fixes for that errata. Then another area that need clarification is the relationship between the MAC VRF, bridge table, EVI, bridge domain, VLAN, and VLAN ID. What are the relationship among them? So we added a section along with the PE model diagram to take care of this. Then another area is for the applicability of the layer 2 attribute extended community to the EVPN service, and to explicitly signal the control word, MTU size, primary and backup bits for a given Ethernet segment, which we added a section to clarify this. Then another section is on the priority handling of EVPN routes, and we have three, basically we've categorized it into the three groups of the priority handling, which I'll explain later in these slides. And also clarification on the best path selection when we advertise a MAC IP route with a default gateway extended community. And also some addition of the how we supporting the DCB allocated label for the ESI, and how we as a result of that, how we handle multi-point to multi-point tunnel in EVPN. Next slide, please. Next slide. Okay. So with respect to the relationship between MAC-VERF, bridge table, EVPN instance, bridge domain, VLAN, and VIDs, this PE model should help. It describes that the EVPN instance gets instantiated with the corresponding MAC-VERF on a PE. And the MAC-VERF consists of one or more bridge tables, and depending on the Ethernet interface mode, whether it is VLAN-based, VLAN bundle, or VLAN Aware bundle, you get either one bridge table or you get multiple bridge tables. Then a VLAN, which is a bridge domain, and spans across multiple PEs. That for that given PE maps to one of these to one bridge table, and that VLAN can be associated with one or multiple VIDs. So This table, this figure and associated text tries to capture the relationship among them and hopefully, make the relationship among these clear. Next slide. So the next slide is the text that goes with that PE model, and I'm not going to get into the detail of it, but it basically talks about if it is a VLAN-based mode, what would be the the association between the EVI and VLAN and the bridge table and bridge domain, what it should be, and for VLAN bundle and VLAN event bundle and so forth. So it makes sure that with respect to these different interface modes, it is these association and relationships are clear. All right, next slide. Then we added a section on the L2 attribute extended community, which this attribute is, this extended community is already defined in our EVP and VPWS RFC. And it is being used there for, and it explains what the, how the primary and backup bits with respect to single home, single single active multi-homing, how these bits works and all that, and we extended that to here for the EVPN service, and we've also described how the flow label and control word can be signaled along with the MTU. So we advertise this extended community with along with two routes. One is IMET route, and then the other one is EtherAD per EVI route. And in case of the IMET route, we advertise it with the MTU control word and flow label fields. And for the EtherAD per EVI, we advertise it with the P and B bits. So we partition basically different bits of this attribute is conveyed with these two routes. Next slide. With respect to the control word signaling, RFC 7432 basically doesn't, it assumes that control word it is there if it is we are doing deep packet inspection, and if it is entropy labeled, then you don't use control word. However, we've extended in here and we say, okay, it can be signaled, and this table shows that what happens if there is a mismatch in the signaling of the control word, and what happens when one PE signals it and the other PE doesn't signal it. We make sure that we keep the backward compatibility with respect to the RFC 7432. So this table is there to make sure that is clear. Next slide.
Okay, Ali, could you go a bit faster, please? I think you're out of time.
Sure. EVPN route priority handling, we divided the EVPN routes into 3 groups for the priority handling. The first group is, of the low scale with the highly convergence affecting routes, and those are first priority, and then We have 2 other routes for the second priority, 3 routes on the second priority, and 2 other routes for the third priority. So this is basically we prioritize the handling for better conversions. Next slide. Best path selection for default gateway is another clarification, that is default gate for IRB interface. You advertise the MAC and IP address for an IRB interface with the default gateway extended community, and there can be mishaps and misconfiguration where you configure the same thing on a host. And we added the text that if these cases arises, how do we handle it, and how do we take care of it? And if there is such duplication, we need to basically give priority to the MAC and IP address on an IRB interface as opposed to a host. So that section
and you have to conclude now.
I think I'm up to the last slide. Next slide is the last one. So a few other additional things. We're going to do it for the Rev 01, and then final slide. Let's go to the next one. Next step, we're going to publish this after this IETF meeting. We want to solicit input, and basically there is no rush for the working group last call in here. We want to make sure that all the stuff that we added here are fully baked and give everybody a lot of chance to read it. So we expect several IETFs for doing this. That's it. Any questions?
Okay, thanks. Thanks, Ali. Okay, Donald's up next, please. TFB.
Hi there. I'll see if I can be a little under my time. This is Donald Eastlake with FutureWay. And this is an update on the status of the VPN BFD draft. Next slide. So basically provides network OAM layer as described in the framework draft. Next slide. So this is a diagram out of the framework draft. So you can see the different levels of OAM, service network, which is between PEs, which is what this draft is mostly concerned with, and the transport, and the link OAM on the various links that connect the boxes. Next slide. Just talking briefly about the other layers. The link OAM, of course, is whatever the link technology is. For example, Ethernet, a popular link technology. You can use 802.3 Clause 57, whose name is Operations Administration and Maintenance, OAM. Transport, depends on the transport. You can use BFDE and or ICMP, trace route mechanisms for IP and MPLS OAM. Next slide. And the service is essentially mostly end-to-end. The PEs need to be aware of it, and use connectivity fault management, which is defined in IEEE 802.1 typically. So the PEs must support the maintenance intermediate point functions, and they should support the endpoint functions. You can do between CEs or from CE to PE. Next slide. As I say, this draft we're talking about is primarily on the network level OAM. The next slide. So it uses BFD asynchronous mode proactive fault detection. The current draft covers MPLS and VXLAN for unicast, BUM traffic using multi-point to point, and BUM traffic using point to multi-point. So it does not consider packet loss or delay measurement, and does not cover multi-point to multi-point. Next slide. So the BFD discriminators are distributed using the BFD discriminator attribute, which is defined in the MVPN fast failover draft. And those are distributed with the appropriate routes depending on which type of traffic and so forth you're looking at. That's a fairly simple attribute, which basically provides the VFD discriminator and has some flags which are currently no flags are currently defined for that attribute. Next slide. So a lot of the text in the current draft and the diagrams related to specifying encapsulations as used in these different cases as listed here. But there's some additional information may need to be provided there concerning the kind of granularity you want to do the OAM at, since it's defined to be operable at different levels of granularity. Next slide. And in the framework draft it talks about the granularity. So specifically changes from the previous version. There's a various initial specification of the routes in which you want to use this VFD discriminator attribute, and how to handle withdrawals of those routes as far as the VFD sessions go and the like. It's added a reference to the draft Mirsky MPLS P2MP VFD, which provides information on cases where you're using the head notification without polling mode for the point to multipoint. There are several different modes for point to multipoint defined in the multiple tail documents and VFD multiple tail. And current draft that I'm talking about specifies that you would use some version which includes head notification. So there's only one mode that doesn't, and there's 3 other modes that do include head notification. And this draft is now referenced, provides additional information on one of those modes. There were various IP addresses specified for the encapsulation. Those have been adjusted based on IESG feedback on other drafts in the hopes to avoid future IESG problems. And there are, of course, miscellaneous editorial improvements. Next slide. So future additions possible, information covering PPV, VPN, IRB. I think it may be useful to have an appendix that actually shows traceability from the requirements that are in the framework draft to the provisions that are in this draft to show that those requirements are covered. And one could conceivably add some information on other encapsulations. Next slide. So basically looking for requesting comments and suggestions, and hope to progress this draft to a point where it could be a working group last call, not too far into the future. That's the presentation.
Okay, you're in the queue. So I do not hear you.
Mm-hmm. There seem to be 2 people in the queue.
Yes, he just needs to unmute himself.
Yeah.
Okay, this is Jeffrey from Juniper. One neat comment, instead of saying MP, maybe just
Go ahead. Yes.
A neat comment, Juniper from Jeffrey from Juniper. So
Yeah.
instead of saying MP to P, just say ingress replication, because
Okay.
you certainly have P2P for ingress replication.
Okay. Well, it uses the phrase ingress replication also in the draft, but MP to P is slightly shorter for slides. Maybe, I don't know.
Okay. Any other comments? Okay.
Can you hear me?
Yes.
Yeah. So Jorge Rabadan, Nokia. About the fault detection for unicast, is it the intent to advertise the BFD discriminator with every single MAC IP route in the broadcast domain, or only one special?
As I say, I believe this draft does need some more work concerning the granularity of OAM testing you're going to do. So this is the network layer, which is between PEs, And you could just want to, I don't think you want to test between PEs if there's no routes between them. But as long as there's one, you might want to just test one path. That would be the worst granularity. If you want to, I believe according to the framework draft, you should be able to test at several stages of granularity, including one which is much finer. But if you're doing more fine-grained testing, then you need to be able to distinguish the VFDs for those different sessions that are testing those different fine-grained paths. So if you have any suggestions on improvements for the draft along those lines, they'll be welcome.
Yeah, I'll send some comments. The other request is to also include IP multicast and the the advertisement of the discriminator also with SPMC 80 routes for EVPN.
Okay, I think perhaps you post some comments like that to the list would be ideal, so that everybody could see them and comment on them.
Sounds good. Thank you.
Yeah.
Okay, thanks. Next up is Linda.
Okay,
Okay, go ahead.
hello? Oh, can people hear me? Okay. This is we want to show that how the BGP is used to control the SD-WAN. The purpose of this draft is to demonstrate to other organizations. For example, IETF has two SD-WAN related projects, and they do have BGP, how to use BGP to control SD-WAN. But I think that BGP it's better for IETF to have the draft showing how we use them, and so just give them a guideline. So the draft itself is pretty simple, straightforward. We have described the services and requirements, and we listed several scenarios. Those scenarios are from SD-WAN project in math. And then we show how BGP are used for each of those scenarios. And then we show the traffic walkthrough. So this was adopted in July to the working group draft. We still would like to hear more feedbacks and comments. Next slide, please. So the major changes, basically we reflect the latest change in the tunnel in cap version 20, and we address the suggestion from the Bess mailing list to use recursive lookup. The recursive lookup is described in the section 8 of the tunnel in cap. So here I'm just show some examples. How do we use that? Next slide, please. So this is from the old version, the 00 version, showing that for the BGP update to reflect the attributes, especially for the IPsec attributes, you have client routes and you have detailed attributes, the IPsec related sub-TLVs, which is described in the secure EVPN. Next slide, please. So this just to show if we use recursive lookup, there will be two updates. The first update will have the client routes and with the next hop to the loopback address. And we tag the client route with the encapsulation extended community with the tunnel type, which can be IPsec or can be some existing tunnel supported. And we use the color extended community. And then the second update is to describe detailed attributes. So an advantage of this kind of recursive lookup is to separate the IPsec property distribution from the client routes, because IPsec SA attributes have rekeying process which need to be updated periodically. When separating them, you can reduce the packet size of the BGP update. Next slide, please. This is also from the previous version. In the ST1 project in math, they talk about different topologies. Some traffic can go through like blue topology. Some traffic can only go through the red topology. And with this update, you can reflect that route, different topologies. They call it segmentation, SD1 segmentations. Next one, please. This is just another illustration of using recursive lookup. So for the blue topology, we have two updates. The first update is the client routes with the extended community specified as tunnel type, and then there's a color to specify the attributes, and then which is associated by the second update. Similarly, for the red topology, we'll also have two updates. Next slide, please. So here is for the hybrid SD-WAN, meaning that the underlay network can be mixed of different different underlay networks. You could have underlay being the internet provided by different ISPs. You could have underlay being the L3 VPN. So similarly, using recursive lookup, the first update is very simple. We have the client routes. We actually need a new tunnel type. We call it SD-WAN hybrid, and then associated with the color. And in the second update, we'll have very detailed description attributes for this hybrid tunnels. So very importantly, that for the for SD-WAN, for the IPsec, for example, IPsec is SA Security Association is always pairwise. That means from CPU 1 to CPU 2, that same port provided by ISP2, like 170.0.0.1, two different IPsecs to different destinations. So because of the attributes can be a large amount of data, some of the IPsec security associations could be pre-configured. So in this hybrid tunnel, we could include pre-configured IPsec SA identifiers. So you don't have to attach those attributes. And you can also include hybrid underlay tunnels for example, if the client route 10.1.1x can be can be carried by both L3 VPN and the internet. Just a side note, there's a draft in the IDR to describe a more optimized encoding for SD-WAN hybrid. We call it SD-WAN NRI, and which will be discussed tomorrow at IDR session. Next slide, please.
Yeah. You have less than 2 minutes to conclude.
Oh, okay. Then I just skip this one. This was discussed last time. This is about the scoping of the propagation. Okay, so maybe I'll just stop here. Next one is encoding, right? It's like very detailed. I hope people can read the document instead of me talking through this. Any questions? Any suggestions? No? No questions? Then I'll end here because the follow-up slides are too detailed to be discussed here. I don't think I have time for that.
Okay.
Yeah.
Thank you, Linda. So if folks can review the draft and post comments to the list. Thank you. So next is okay.
All right. So, this draft, it's about PBB, EVP, and ISIT-based CMAC flash. This is the list of my co-authors. This is working group draft document, and the idea is that you know, it's ready for last call, and we should make sure that we get the you know, the work done. Agenda short refresh, some history and some conclusions at the end. Next slide, please. So what this is about is ISID-based CMAC flash for PBB EVPN. So in PBB EVPN, we still learn CMAX in the data plane, right? And they are subject to aging timers. So whenever you have multi-homing and you have physical or logical failures, you need to send some CMAC flash notifications so that the remote PEs can actually flash the MAX and relearn again. So RFC 7623, PBB VPN defines some CMAC flash mechanisms, but only for single active multi-home Ethernet segments, but not for other use cases like virtual Ethernet segments, or when, you know, the multi-homing is managed by the CEs, like in the case in the diagram, where you have G8032 access networks or active standby to the wires, you know, managed from the CE. So what this draft introduces is a generic ISID-based CMAC flash that works with virtual Ethernet segments, regular Ethernet segments, and it uses what we call BMAC ISID updates with incremental sequence numbers. This is nothing else but a route type 2 with a BMAC in the ISID for which we want to flash the MAX encoded in the Ethernet tag ID field. And this is backwards compatible with RFC 7623. I should have said 7623 and not 7432. Next slide, please. So we started with this draft in 2016. It was developed over the next few years. We had multiple revisions, and in the meantime, it was implemented and deployed in large PBB VPN networks. Back in 2019, we had a discussion in the working group because there was an alternate ISID-based CMAC flash procedure in the virtual Ethernet segment draft. But the outcome of the discussions was that we would standardize the CMAC flash procedure in this document and remove the procedure in the virtual Ethernet segment draft. And as a result of that, we adopted this document in October 2019. Next slide, please. So what is new in this revision? So some terminology added, a new section for just for terminology, some typo fixing, and a general review with minor clarifications just to make it ready for last call. Next slide, please. So we believe it's ready for working group last call, and it should progress as soon as possible. So if you have any comments, welcome. All right, if not. All right, so the next one is about multicast source redundancy in EVPN networks. So this is the, I think it's the second or third time that we present this draft. This is the list of my co-authors. Next slide. So we'll do a very short refresh since we presented this draft already in the past. I'll focus on what we are adding in revision 02, and we'll end up with some conclusions. Next slide, please. So the goal of this document is to define a solution for multicast redundancy in EVPN networks and avoid any packet duplication that may happen as a result of that redundancy. So it addresses the redundancy for multi-home sources, redundant single home sources, and also redundant multi-home sources. And it works for sources within the same broadcast domain or a different broadcast domain, or a mix of both. So we want to cover all the potential cases. And so the packet duplication may happen because the assumption here is that redundant sources are sourcing traffic for the same flow, for the same multicast flow. And we define here a new concept, which is the single flow group. And this refers to a multicast group, which represents traffic that contains only a single flow, right? And the multiple sources may be transmitting the same SFG. And as a result, when you have, like in this diagram, you have a receiver 21 that is requesting to join, star, G1 group, we don't want to have duplicate packets on this receiver. So we need a way to avoid that. Next slide, please. So the draft defines two redundant solutions, the warm standby solution, WS, or the hot standby solution, HS. So the first one is interesting because it only requires that you upgrade the upstream PEs that are connected to the redundant sources, but not the rest. It's completely transparent to the downstream PEs. What this requires is pretty much the upgrade and configuration of the upstream PEs. So in this example, that would be PE1 and PE2. You need to configure what the SFG is and where those redundant sources for the SFG exist. Then once you do that, we signal the location of the sources, the redundant sources. We use SPMC80 routes in EVPN for that. And we include a DFLection extended community and the special flag in the multicast flags. So with this DFLection extended community, we run what we call an SF election, or a single forwarded election between the upstream PEs connected to the same sources. And so between them, they will select only one single forwarder. So with that, as a result of this election, the upstream PEs, they will program some RPF checks, right, for the SFG, so that the non-SF PEs, they will discard any received packets on the local AC for the SFG. And the SF PEs will accept those, but only from one local AC. So after that, basically, we receive, the SFG flow on the single forwarder PE, and I will forward that, and the receivers will get a single copy of the SFG. So next slide, please. There was a need also for another solution that is hot standby. And the reason why we needed this is because we want to have a faster convergence. The drawback of this solution, though, is it requires all the PEs to be upgraded. So not only the upstream PEs, but also the downstream PEs. But other than that, basically the procedure is it's described here. So we need to configure the SFG and the BDs, the redundant sources are going to be attached to. We introduce some control plane extensions. So because on the downstream PEs, we need to detect or determine whether a multicast flow is coming from a given source or another. We are including ESI labels to make that distinction. So those ESI labels are signaling SPMC80 routes, and the other extension is that the ESI routes, they must be domain-wide block labels, because we need to make sure that the same ESI label is used from the two PEs here for the same source, right? And those ESI labels are different on a per redundant source basis as well. So that's why they must be BCP allocated labels. So based on that, we advertise those labels also on the AD per ES routes, and we program RPF checks on the downstream PEs so that we, upon receiving, the duplicate flows from the two sources, the downstream PEs, they actually discard the packets coming from one source, and they forward only the ones for the primary source. For fault detection and the change in the programming of the RPF check, we rely on the advertisement and withdrawal of the AD routes, but BFD is possible too. So next slide, please. So what did we do in revision 02? Some general cleanup with typo fixing. We also improved the terminology section. We added an optional use of BFD with the reference to the EVP and BFD draft that was presented earlier. So that's why I requested to the authors, or I will actually formally request to the authors of the BFD draft to include the signaling of the BFD discriminator along with the SPMC AD routes, which is needed in this draft. And we also added some security considerations to the document. Next slide, please. So what we are requesting is working group adoption. We believe, we've worked quite a bit on this draft. We've presented it a couple of times, and it's ready for working group adoption.
Thank you, Jorge. Okay, so I have a couple of minutes for any comments or questions. I don't see anyone in the queue. Thank you.
Thank you.
Right, next is Sammy.
Hi, can you hear me?
Yes, loud and clear. Thank you.
Okay, good. Yeah, this draft is, as the name is showing here, is about ELAN services. So it's the old ELAN technology that we are all aware of, but I think here it's talking about how can we provide the ELAN service in an optimized way, benefiting from the new segment routing transport. So whatever segment routing transport is offering, how can we benefit from that to provide the overlay ELAN service in light of the new capability offered by segment routing. So those are the list of authors that have contributed and co-authored the draft. So as you see here. So let's move to the next slide, please. So the motivation here is how can we provide the service, the ELAN service, that historically, of course, started with pseudo wars, if we are talking about the core of the service provider network. And we have started with VPLS, and then later on came on EVPN as well, and how the history developed along to for the ELAN service, and now with the benefit of SR, how can we achieve some optimization for the offering? So in general, the motivation here is more how can we simplify control plane and data plane and address as well, maybe some of the issues that historically was present with the pseudo-war technology or the VPLS technology that's widely deployed even today in service provider networks. So if we go back to the history of the pseudo-war, historically provided a context that identify both the service and the endpoint. And because the pseudo-war had that context that identify both the endpoint and service, it did suffer from some scale issues. So here is an example. If we are talking about 10K service deployed on 100 node, we are talking even with partial meshes, between those servers, not on all 100 nodes, I mean. We are talking about needing to signal more than 100,000 pseudo-war in control plane for those different services. So of course, the scale was a concern that VPLS was suffering from, and as well, pseudo-war in general followed the layer 2 semantic, which didn't have active-active redundancy. And those semantic of not having active-active redundancy was primary motivation for EVPN, for example, to come and offer the active-active redundancy, and as well solve the scale problem by providing the multi-point-to-point LSP for the EVPN service. Of course, when EVPN provided that multi-point-to-point service, it removed the source information from the context for the EVPN instance, and that mandated that EVPN has to advertise the MAC address in control plane. So what here we are proposing with that new idea of SR optimized ELAN is benefiting again from the segment routing, is that we can really improve the scale by simply splitting the pseudo-war context instead of having it only presented by one context or one label as we have for the pseudo-war, is split that and have the pseudo-war presented by the service label and another context to identify the source. So now pseudo-war can be sought as one SID using the segment routing terminology here to identify the service, and another SID to identify the node that's gonna be sending the traffic associated with that layer 2 service. So that split can allow us to scale, and now instead of needing hundreds of thousands of pseudo-war context, the service can be presented by only 10,000 service instance context, right? We still, with the SR optimized here, maintain the pseudo-war semantic or the point-to-point semantic between two endpoints by presenting, as mentioned here, the pseudo-war context with two SIDs in the SID stack, which is the service SID and the source SID. And as well, what we are saying is that we can offer still the active-active redundancy by simply benefiting from the Anycast SID capability offered by segment routing today. So how is that going to be achieved? We are going to see that in the next slides. So next slide, please. So here, as if we go back to the motivation and the goal here, we are saying we want to, of course, benefit from SR or segment routing, but at the same time, we want to as well optimize the control plane or simplify the control plane. So what we are saying is that if you see here a network with 6 nodes as shown and CEs attached, whether those are multi-homed or single-homed to the different PEs on that network, we are saying the discovery can be greatly simplified by simply having each node advertise the service SIDs as a bit mask of all the services that are provisioned on a given node. So if you imagine, some nodes here are, for example, configured with 1,000 even of services, each node can advertise a bit mask of all the service SID IDs, starting with a start service SID. I think here, the assumption is that we are going to have a global service SID block, right? So we are going to have an sRGB for the services. But how are we advertising those service SID will simply be a start service SID plus a bit mask where each service in that block is set if the service is configured on that node. And this is how all nodes in the network can quickly discover what services are configured on its peer nodes, right? And that can help, of course, to discover the membership for ingress replication, for example, if you are going to be flooding layer 2 packet, or to build point to multi-point trees, for example, if that's needed as well. So the discovery of many services can happen using a single control plane route, right? That can be, of course, flooded using a BGP control plane to the rest of the network. And along with that bit mask, we can advertise per node, especially for ingress replication, a per node broadcast SID. So that SID is a node SID still, but that allow the node to receive broadcast traffic. So if the top SID is that broadcast node SID, then the node know that this traffic is meant to be broadcasted or meant to be flooded to the service. Okay? So having said that, let's go to the next slide, please. So in here, we are describing how can you achieve active redundancy with this new idea here as shown. So we are talking about, as mentioned again, the stack here. In the stack, we are going to have the service SID and the source node SID presenting the pseudo-war context, right? So what we are proposing here is that for each Ethernet segment that's multi-homed, we are going to have an Anycast SID associated with it. So that Anycast SID, is going to be advertised or flooded into the network by IGP, but it's presenting, or BGP for that matter, but it's presenting an Ethernet segment. So when that Anycast SID is going to be flooded to the network, then the nodes attached to the multi-home site can discover that they are configured with the same Anycast SIDs that's associated with the Ethernet segment. It can help them do their DFL action. And at the same time, when we do data plane MAC learning here, we are going to be learning the MAC that's sourced from a packet coming from a multi-home site against the Anycast SID. So the MAC learning, maybe I should touch on that a little bit, is that the MAC learning here for a given service is going to be associated with the source node SID. And that source node SID could be, unicast if the traffic is coming from a single home site, or could be, it could be associated with a unicast node SID, or could be an Anycast node SID if the packet was coming from a multi-home site. So the learning still can happen against the source node SID, whether it's Anycast or regular node SID that is associated with the node that receives the traffic from a single home. So having said that, let's go to the next slide. Okay.
Sam, can you speed it up a bit, please? Because we've got quite a few people in the queue as well. So
I think I still have 5 minutes, right?
5
minutes. Yeah, I know. Okay, so again, the optimized service with data plane MAC learning here, as mentioned, again, repetition on the flooding We are gonna, of course, the data plane McLearning, everybody's aware that we do flood and learn here, and we are learning again the source MAC against the source set, right? And everybody would learn that, and that source set could be a node set if the traffic coming from single home, or an anycast set if the traffic is coming from a multi-home. So we can move to the next slide. Okay, yeah, one key feature as well, talk about ARP suppression and how we can achieve ARP suppression with that idea, right? So one approach here that can be deployed, of course, we can learn about the IP MAC binding by gleaning ARP. However, the ARP replies are typically unicast, and IP MAC binding may not be learned except only via the nodes that are involved with that unicast packet. Here, a proposal of flooding ARP replies to allow the IP MAC binding to be learned via all nodes as well, to be able to provide ARP suppression. Yeah, let's move to the next slide. Yeah, actually, in here we are saying, mechanisms that are required to provide overlay convergence are not needed here, and that's honestly a very key to this approach. So, as we said, we are simplifying control plane mechanism by advertising very, very limited number of routes to discover the services and build to discover the services are configured and learn about them in control plane with a much simplified control plane offering here. But as well, in terms of convergence, given that the Ethernet segment is presented by an anycast set in the underlay network, we can use the overlay, the underlay convergence to converge the overlay as well, right? So there is no need really for any overlay convergence in here, because simply a node can withdraw its anycast set from the underlay network, then it will stop receiving multi-home traffic or traffic that's destined to its multi-home site. And we are saying here, even for faster convergence, the node can direct traffic to another node associated with the multi-home site if its own site, for example, failed, until the withdrawal has been propagated to the rest of the network. So let's move to the next slide, please. Yeah, we are saying, of course, because we are using anycast set, we can do ECMP multipassings. This could be ECMP or even UCMP, right? Because the anycast set can be advertised with different weight, and if that happens, we can send traffic with different weight, and as well of course, to the nodes attached to the multi-home site, or as well. We could have active standby by having one node advertising the anycast set with a higher metric. Next slide, please. I think, yeah, this is the last slide. So just to recap quickly here, we are saying
you have to conclude now.
Yeah, I'm concluding. So just to recap quickly here, we are saying, okay, hey, we are maintaining data plane McLearning with all the benefit of data plane McLearning with this approach. To achieve, of course, fast convergence. And, data plane McLearning has been optimized greatly on hardware today, and many hardware can do McLearning at line speed. MacMove, maintain conversational learning, scale very well. We bring the benefit of active, and multipassing through benefiting of SR anycast, and you mentioned as well ARP suppression. Much simpler control plane. Imagine one route that can teach you about all the services associated with or configured on your box, right, or on your router. The leveraging of the segment routing and eliminating any need of overlay convergence. So only underlay convergence is needed, eliminating the need of any overlay convergence. With that, yes, I am on time, 15 minutes. I concluded. So, any question?
Okay, I think Ali was first in the queue.
Yeah, sure.
Ali, do you have a question?
Hello?
Hello.
Can you hear me?
Yes.
Yes, we can now.
All right. So there are quite a few claims that are inaccurate, and the idea of these data plane learning, Mac learning in data plane, and breaking the pseudo-wire context into source field, service ID field, and the destination, which is a multicast field, has been done for over 17 years. First, in 2003, 2004, I wrote a draft VPLS multicast that describes how to do that. And then 7 years later, in 2010, there was a the native VXLAN draft talks about data plane learning. And between the two, we had PBB VPLS, which does the same thing.
Sorry, Ali, what is the point? Sorry, what is the point? You know, are we getting a history lesson? Or
I am getting to the point. I'm getting to the point that there is nothing new here. Claims are being made in here which are inaccurate, and there are issues, all the issues that we have with the data plane learning, it is still exists, except that you're not, either you don't know about them or you're not mentioning them. Okay, so what are the issues?
You know, let's not make statements. Let's not make statements.
Let me go over the issues, Sammy, and I'm going to send the email on the working group. On the
sure, yeah, you are welcome to send. You know, I don't like subjective comment here and just.
It is not a subjective comment. It has been around for 17 years, for God's sake.
Actually, you know what? That idea, you know, even with other vendors I worked for, I have been even talking about it 20 years ago. So what is the point? I'm not getting it.
The point is the same issue that we had with the data plane. How come you're not overlooking?
Why you are thinking that data plane is evil and we shouldn't do that?
Hold on, guys. Listen. I'm not. Let me go just over the issues. Flooding issues. Okay, when you talk about the all active.
Okay, let's talk about flooding issue. Why are you saying flooding in data plane is bad, but flooding in control plane is good?
No, I'm not even talking about
you are saying, you know, why are you saying flooding in data plane is bad and flooding in control plane is good?
Let me talk and then respond once you understand my question. Okay?
Yeah.
Flooding issues.
Yeah, could you do it really quickly and continue on the list, because we have then 3 people that are still in the queue and still 1 slot to do.
I'm gonna actually elaborate on that in the mailing list, but I'm just gonna mention there is a flooding issue as a result of the all active multi-homing, where CE does the hatching to one PE and let's say to PE1 and PE2 doesn't receive, and then when the remote PE sends the traffic to PE2 that hasn't learned the MAC address, the PE2, that multi-home PE is going to flood. One. Second,
actually, that's not correct. That's not correct. Why are you saying, why are you assuming this is the case? You know, I don't think you read the draft or even looked at the slides.
Yeah, I'm really sorry, guys. I'm really sorry. We are really out of time. So could you try to discuss on the list and stay calm, okay?
So don't just want 2 other things.
Ali, we have 3 other guys that
balancing. So, all right. Hello.
I think Tom was next. Very quick, please.
Hi, Sammy. I have one particular question in the draft, section 4.1. It mentions that the BTP extension will be provided in another draft. It seems to me that this is either, you know, something in Bess that's reinventing EVPN, or is better discussed.
I mean, the draft has nothing to do with EVPN.
Well, that's even more concerning. But also, I mean, this is the BGP enabled services working group. Would this draft not be better discussed in spring at this point, given that it is purely about
yeah,
SR?
we can discuss the draft in spring, but the idea here is that this is an ELAN service, and we didn't define yet the extension for BGP to support this. So this is why we are presenting here, presenting the draft here in Bess, right? So,
but there's no BGP discussion
no,
at all.
actually, there is BGP angle of it that are going to be added to the draft shortly, right? You know, the part about distributing in control plane, the set of ELAN services associated with a given node.
Okay, and very quickly, why do something different to EVPN?
Why we are okay? The main motivation here that we mentioned at the beginning of the presentation is that we are saying we want to have a much simpler control plane to set up scale better in terms of control plane in distributing the service. Actually, if you are talking about EVPN, if we are going to go EVPN route and signal, for example, on 100 node, 10,000 service with MAC entries, you are talking about millions and millions of routes that you have to distribute. So we are saying, you know, instead of that approach, why can't we, you know, if you talk about EVPN and you have 10,000 servers, you are talking about distributing 10,000 Ethernet AD per route. You are talking about distributing Ethernet segment. You are talking about IMAX routes. You are talking about hundreds of routes.
We have to move to the next slot. We have to move to the next slot, unfortunately.
Okay, out of time. Next is, so please take any of your questions on this draft to the list, please.
Yeah,
Jeffrey.
And Jeffrey.
Yeah.
Okay, so I just want to say that this concept is actually independent of SR. Okay. All right. So, my comment was about the semi-strap, but now let me get on to my presentation. This independent generic fragmentation, it's a use case that started with EVPN MPLS. Next slide, please. So observations that with EVPN MPLS, we have this fragmentation issue in that if you receive a packet from CE that is too large, today the only way to get it through the underlay is to use IP encapsulation. You put you impose your service label first, and then you put the packet into IPv6 or IPv4, fragment it, send across, reassemble, decapsulate IP, and then go on with MPLS-based forwarding. This works, but MPLS is not used for transport, and there are cases where an operator may want to use MPLS transport. And it also could incur large IPv6 overheads. So this fragmentation issue, for when it comes to pseudowire or VPLS, there was a solution, RFC 4623, using the control word, but that is not applicable to EVPN because EVPN, the two reasons. One is EVPN either does not use control word, or when it does use control word, it's all zero. It does not have the sequence number in it. The presentation reassembly was this is unrelated. So the second observation is that IP fragmentation can actually be viewed as independent of IP. So as long as the context for that identification in the fragmentation header is available. Next slide, please. So the proposal here is to provide independent fragmentation and other functions in a shim layer without requiring IP. So in this EVPN MPLS example, after ingress P imposes the service labels, then it will fragment the packet without IP encapsulation. To do that, we use a generic fragmentation header. And in that header, there is a next header field, and that will be set to MPLS to indicate that after the GFH, there is the MPLS payload. Now, compared to IPv6 fragmentation header, this GFH will have additional information about the source. Now, the ingress PE impose a GFH label, basically saying that next header is a GFH header. So then it will impose the transport label and then send the traffic. Now, the egress PE sees that label and knows that the GFH follows, so it reassembles the packet and then hands the packet to MPLS for further processing. Next slide, please. So the fragmentation header, the first one is the IPv6 fragmentation header, and the next one is this generic fragmentation header. The red fields are the differences from the IPv6 ones. The first one is that 0 bits at the very beginning. That is for ECMP issue. So there have been some discussions on the MPLS PALS and Bess mailing list. And this ECMP issue was brought up by Stuart. And so this is a solution for that ECMP issue. This is just same as the first 40 bits in the pseudo-wire control word. I want to say that it's not in the draft yet, but I'm here presenting here because of discussion. The identification field is variable because there are cases we need to embed the source information in this identification field. And when that is the case, then there is the flag bit S bit set to indicate that the identification field itself includes the context information. So the context from the outer header will not be used. And because of that variable identification field, we need a header length in this GFH. Next slide, please. This slide, I already talked about it, so we can get to the next one. Next slide, please. So coming back to the motivations, first, it solves the EVPN fragmentation issue without requiring IP transportation or incurring IP overhead. In addition to fragmentation, the other functions provided by IP that can be supported at this independent frame layer as well. ESP is one example. And in fact, this fragmentation or ESP functions, they can be applied to many layers, including MPLS, beer, or even Ethernet if IEEE so desires. So it's truly layer independent. And when it comes to beer, the beer encapsulation header has a protocol field that can specify that the next header is a GFH. Next slide, please. Okay, so we are basically seeking comments. There have been presentations and discussion in various working groups and about use case. And if this is a solution that we do want to work on, then we need to find a home. Right now, our draft is for TSV working group, but it can be any group that we deem appropriate. Next slide, please. Oh, actually, no more. So I'm done with the presentation.
Okay, we may get cut off, but first in the queue, Stuart.
Okay, so thank you for improving the draft a little bit. I'm still worried about how you're going to prevent reassembly lockup, because basically you've got nothing to clear the resources if subsequent packets fail to arrive to complete the packet. And I do wonder whether you should have looked also at using the pseudowire header design with just adding an identifier to it. But I'm still also worried about this design in that I'm not quite sure what problem we're fixing, because if it's IPv6 you're running, then PMTU discovery will fix the problem. It will automatically back down for you.
So let me answer the third question first. There are cases you cannot ask the traffic source to do the fragmentation. For example, you are a EVPN provider, and your MTU is limited, and yet you are supposed to provide transparent services, and you cannot ask your customer to say that, hey, you need to tone down your MTU. So that's the use case. I think and then your first question is what was the first question again?
Reassembly lockup.
Okay.
So you've got all these sort of stray fragments lying around in the egress PE.
That's a generic problem that's even if you are not using this one, let's say you are using IPv6 encapsulation and you fragment using IPv6, or even in the pseudowire case, when you do have fragmentation reassembly based on the sequence numbers, a egress PE could have many of those ones. It's the same problem.
Not in a pseudowire, because a pseudowire is a point-to-point solution. So the next packet must be for the pseudowire and will release the lockup. So you will never have any more traffic going across your pseudowire again, or it gets released.
Well, actually here it's somewhat related to what Sammy was saying. Sammy was basically using the source state to introduce this pseudowire context into this EVMP concept. So here is the same thing. The context either embedded in the identification field or in the outer header will give you that pseudowire-like context. So we can discuss that more, but I think it's the same thing. And then your second question or comment, what was that again?
Can't remember what it was now. The key ones were PMTUD, and which will happen naturally, right? It's just you don't have to do anything; that automatically happens, and the lockup problem.
Okay. Yeah, we can continue offline. Yeah.
Lacey, do you want to?
Yeah,
I
have to admit, I only read this during the spirited discussion of the previous draft. From a procedural standpoint, you might have to split up the signaling from the transport aspects. It might be better since they're different areas. That's just procedural. And there's also some details in the OSPF-v3 that need to be changed, but that can be done. I have one question. Like I said, I didn't really, I only just read through this draft quickly. I don't really understand where the fragmentation is being done in the ingress PE, right?
Yes.
Okay, wouldn't it have the state already of those labels? Rather than having to signal them across the, say, the VPN domain? I don't know. Maybe a picture or something would be good in the draft, because it seemed like there was a lot of knowledge. I couldn't visualize the problem in the quick looking at it quickly.
Okay, I'll add a picture, but a quick answer is that the labels, I assume you're referring to the GFH labels.
Absolutely, yes.
Okay, the reason why they are needed is that MPLS does not have a way to indicate what is the next header, what follows after the bottom of the label stack. So that label, GFH label, will serve the purpose saying that, okay, the next header is GFH header. And then additionally, that label can optionally identify, say, which source, which node send this packet, in addition to the GFH semantics. And that is
That would be
also
like that would be like the CE, right? The CE, right?
no, the PE. I mean,
the PE. Okay.
Yeah, and that is actually very similar to the source said in Sammy's presentation. It just happened that the two presentations are somewhat related, even though I just realized that that point. Yeah.
Okay, thanks.
Okay, Stuart, did you want to make another comment? You're back in the queue.
So I remember what my other question was, and you kind of alluded to it, but you haven't really answered it, which is, I'm not sure why you need type information here. The way MPLS works is that the payload type is implicit in the label itself. So I'm struggling to understand what the point of the next header is, other than to sneak in an MPLS type without further discussion.
You mean the next header value field in the GFH header itself?
Yeah, yeah. I mean, everything else we've done on label typing. So this is a change to the MPLS architecture.
No, the GFH label indicates that a GFH follows, but how do we know what follows after GFH? So that's why we need the next header in the GFH itself, because it could be that after the GFH header is no longer MPLS. It could be IP, or it could be whatever, anything else.
Well, how did you know that to start with? I mean, we built everything else without needing that information. So presumably you were expecting this to be an Ethernet frame or a something else frame when you set the pseudo wire up, and all you've done is all you need to do is to provision this particular pseudo wire such that you expect to find the fragmentation header there. And it's probably simpler to always send the fragmentation header.
Not necessarily. When there is no need to do the fragmentation, then you don't need that GFH. And in the EVP and MPLS case, definitely after the GFH, it's a MPLS another MPLS label stack. Basically, it's the service label. But there could be other use cases where after GFH is no longer MPLS payload. So
I think this needs a discussion in the MPLS working group.
Definitely, I also have a presentation scheduled for MPLS working group, and we do want to have more discussions in the mailing list as well, which you have started. Thank you.
Okay, I think we probably should wrap it up now. We're 10 minutes over. Unless you have a 10-second comment, AC. Oh, you've gone. Okay. So thanks very much, everybody, and see you next time.
Bye.
Thank you. Bye.